Hello everyone, we're going to talk today about Dijkstra's shortest path algorithm using global positioning system.
The agenda of this presentation is the context, the issue and problem, definition, experiments, observations, results, and conclusion and future scope.
So this research presents the Dijkstra's shortest path algorithm, in which we add the position parameter using the global positioning system. The current position can be retrieved at any point, and this paper also discusses the related work, proposed work, results and analysis, conclusion, future works, and the references at the end.
The issue and the problem here are to be able to discuss the determination of the shortest path between nodes using the Dijkstra algorithm and the GPS simultaneously. In this paper, we will be mentioning the position parameter between these two algorithms.
So a basic definition about Dijkstra's algorithm. It was invented by Dijkstra, a Dutch computer scientist, in 1956, and then it was published in 1959. So basically it is a graph-based search algorithm. It solves according to the shortest path and can only be applied for the positive weights. And the weights in this context represents both cost and distance, which are always positive, and the distances cannot be negative, so it can be applied.
The Global Positioning System is a system designed and operated by the U.S. Department of Defense, the DoD. It is a satellite-based system which is used to locate any position on Earth. It has different parts which can be categorized into space segment, control segment, and user segment. The space segment includes satellites, control segments include control and monitoring station, and the user segment has the GPS receivers. The way it works, the satellite sends radio signals into the control station, which monitors and corrects the signals and then sends them back to the satellite using the ground antennas. The GPS has different functionalities, which can be categorized into general ones and real-life everyday example ones. The general ones have the determination of positions of any location, navigation from a location to another, to be able to create digitized maps and determine distance between any 2 points. The real-life everyday examples is for parents to track their children, for the purpose of tracking animals, for delivery services, and for fire services.
So for the experiment part, the distances are calculated using the Euclidean mathematical rule, which is the square root of x2 minus x1 square plus y2 minus y1 square plus z2 and z1 square. And the coordinates of the nodes are retrieved from the GPS system. So the model proposed for this algorithm is to identify the source and then turn on the GPS system in order to find the current position of the coordinates of the position, then calculate the distance between the two nodes using the rule above, and then set new node as temporary location and update the visited ones. Make sure the node has the lowest weight as it is the minimal distance between the two nodes. And then check if the destination is reached. If not, then repeat step 5 and step 6 until we reach the destination, and that's how we can find the shortest path. Part 2 of the experiment is that the proposed algorithm is to set all the unexplored distances to infinity, which is the maximum distance, and then get current position using GPS. Choose a point to check if it has least distance and add it to the visited ones, and at the end get position of visited node, find the distance, then check if it is the shortest, then return it, else return the shortest one. So this is an example about the algorithm which uses a graph. So we have here A as a source node and F as a destination node. So let's take into consideration the first part in which A will return B and C as the next nodes. the distance from A to B is 3 and the distance from A to C is 5. The algorithm chose B as the next node, which has the minimal distance of 3 instead of 5. So then it will go on for the next steps until it finds the shortest path, which is A, B, E, F.
We have observed that a lot of errors may still occur despite the accuracy of this algorithm. Sometimes the algorithm may not be able to detect the user's position precisely. To be able to correct these errors, we have used pattern recognition techniques. The directions become generated according to the geometry of the maps and not according to the table of each node or the radio signals. In this paper, we have only used theoretical ideas and steps of the process where we have not used any implementations.
For the results, we have observed that the minimal distances are always selected because they are the most accurate ones, while the maximum is not selected and it's not accurate. And based on the aim of the algorithm, it's to select the shortest path, so the minimal distance is always selected. The distance can be retrieved from the rule, which is radical x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared, as previously mentioned. And then this graph shows that the destination is reached within the minimal distance possible.
To sum up, the Dijkstra algorithm is used to find the shortest path, simultaneously working with the GPS to be able to get the current position of every node, and then calculating the distance between our current node to the node we want to reach. The concept of GPS is also used in other algorithms such as A*. In this paper, we have mentioned that we have only mentioned theoretical concepts and we have not used any implementation, but we hope in the future that we would be able to implement this algorithm practically. These are the reference lists where we got the information from for the paper. And thank you for your time.
Thank you for your time.